Welcome back, chat. Today we are going to go ahead and channel that infinite aura and make sure that this lesson slaps. Let's get into it. Gosh, I'm cool. I'm so cool. All right, so we're in biology, and we are going to start today looking at chapter 2, section 3, and I don't know why I'm doing it that way. Too bold, first and foremost. 2, too thin. Here's my Goldilocks zone. I can feel it. 2.3 is our focus today, and we're just going to start it. We are going to look at the cycling of matter. Now, when we look at this stuff, we are not in a physics course, we're not in a math course, but we do need to make sure that we understand just the basic ideas of what's driving all of this. So we work in, obviously, on our planet, and we are working in biology, and our main focus is on one particular sphere within our planet. Not like, I'm trying to think I want to use the right language here. We are looking at a collection of many different biomes that we call the biosphere. Okay, so check it out. Within our biosphere, there are several different natural cycles that our planet and our life on our planet goes through. And I don't need a vocab here. We're just going to look at biosphere cycles. Now, when you hear cycle, remember it just means we repeat and repeat and repeat. The seasons cycle throughout the year over and over, right? Just continuously, because that's how our planet's weather system works. Yes, sir?
Is it cycle or silent?
Definitely cycle. Thank you. Yesterday, I don't know what class it was, I was writing something up here and somebody says, whoa, look at the window. And I looked and I wrote the word window, like mid-sentence, just because I was looking at the window and it just came, it was odd. Anyway, what's matter?
Solid, liquid, gas kind?
So it could be a solid, it could be a liquid, it could be a gas, it could be a plasma.
It has to do with the space.
It could have to do with space. Are you made of matter?
Yes.
Am I made of matter?
Yeah.
Tell me something that's not made of matter.
Air.
Air is made of matter. You just can't see it.
Light.
Light is not made of matter. Light is made of photons. So when we talk about matter, we're going to say two easy things to hit. Matter, from a scientific standpoint, is anything that takes up space. So it has to have a size. It takes up space, and it has to be made of measurable stuff, which we'll just say has mass. Now, for our purposes, we're not going to go super crazy into it, but mass is the amount of stuff inside of you. Weight is how hard gravity pulls on you on that mass. So, do I weigh more on Earth or on the moon? Earth. I weigh more on Earth. Like, let's say I weigh 200 pounds, roughly. On the moon, maybe I weigh like 110. What's my mass on this planet? I don't think I'm obese. Yeah, maybe, I don't know. I got dad bod, I don't mind. If I weigh 100 pounds on the moon and 200 pounds here, and I'm making up the number just so you know, my weight's different.
Yeah.
Is my mass different?
Yeah. No.
Do I have the same amount of stuff in me
Yeah.
that's here and on the moon? The difference in weight is due to gravity, right?
Yeah.
I'm still made of the same amount of
Yeah.
stuff, and it's typically measured in kilograms. That's what we mean by mass. Luckily, when we're talking about the biosphere, we're on the planet Earth, so we don't have to worry about all that necessarily. Okay, now, beyond that, we talked briefly about the difference between soil and dirt.
Yeah.
What's the difference?
The soil has nutrition.
Ooh, it has nutritional value or nutrients? Now, you guys probably know the word nutrients. Maybe. I'm sure you've seen it. Apparently you have. What does it make you think of when you hear nutrients? Vitamins? I'm cool with that. Maybe, depending on how hardcore you are, you might know the difference between macro and micronutrients. If you have ever tried to get big through lifting or something like that. I don't know why I used a colon here. I'll stick with it, but I will go back to my regular arrow for definition stuff. I don't know why it changed. Okay, nutrients. I'm cool with that. How would you explain what it is? Could be a vitamin.
Protein powder.
Protein powder could be full of nutrients. We eat food to get our nutrients, right? Okay, and specifically we eat food, and food is made of what? So yes, it is, but we're going to take a longer trip to get to that. Say it again? Matter. I would agree with that. just take one smaller step. Do you agree it's made of chemicals? Literally everything is made of chemicals, right? Because we're all made of something, and that something happens. Yeah, they're compounds or substances, those sorts of things. Nutrients, we're just going to say are chemical substances. And I don't know why that would come out capital, so we'll fix that. Chemical substances that all organisms need, and I'm just going to say that organisms and just imply the all part, that organisms need to sustain what?
Their life.
Good. Need to sustain life. Now, for this, it is a really, really big process for our bodies to stay in equilibrium and keep everything balanced as it should be. Is water good for you? Is too little water bad for you?
Yes.
If you don't drink enough water, you become what?
Dehydrated.
Dehydrated, and that's obviously bad for people. What if you drink too much water?
You'll get
Overhydrated.
You get overhydrated. It's actually called water poisoning. You can drink too much water. Do you guys drink a ton of water? Okay. So some of you do, some of you don't. There's some weird things about just nutrition and what really counts as water, because almost everything you eat also has water in it. Cool. Why do you get sick, like possibly to the point of like not being able to live anymore if you drink too much water?
Because
You say cramps? So maybe it has something to do with cramps for sure. Why would too little water make me sick and too much water makes me sick?
there's no nutrients in it.
So there aren't nutrients in water, not meaningful anyway, unless you get like fortified water, but that'd be weird to get
your
that.
body can function anymore.
Yeah, so we need salt in our body,
Yeah.
right? That's, you don't think of it as a vitamin necessarily, but it is vital to our survival because salt winds up being how our nerves send messages. Too little water makes our blood and everything too salty, and then the signals get wonky when there's too much salt in your blood and anywhere else in your body. If you drink too much water, you're diluting that salt in your body, and similar issue. Like electrolytes, you guys have probably heard it. What's the sports drink you guys? Gatorade. It's made of electrolytes, right? It's silly. It has salt in it to replenish all that stuff that you sweat out. Whether or not you really need it in the form of Gatorade or not, I don't know. But
They always say drink water before and then electrolytes after.
yeah, so I'll tell you the rule of thumb. How much water have you been told to drink per day?
50 glasses.
8 cups. That's 64 ounces. That's 2 liters or half a gallon. But that's not the same for everybody because, believe it or not, who's the smallest person in our school? Somebody that's short, like tiny.
The eighth grade.
Who?
Say she's one of the shortest.
Deseret?
Yeah.
Okay. So Desi needs to drink water, right? I'm significantly larger than Desi. Do I need to drink water?
Yes.
Should we really both drink the same amount of water, you think?
No.
No, probably not. That 8 ounces is a good kind of rule of thumb. However, take your weight, divide it by 2. That's how many ounces roughly you should get. It's not perfect. But like if I'm 200 pounds, I should drink 100 ounces of water. Roughly. I don't know. I haven't stepped on a scale in a while. Between 190 and 200, I would assume. Cool. Anyway, let's start kicking through here. Now, we're going to write a big ugly word, and this is actually going to be just within here. So, ugliest word that we've seen this year, I think. Bio indicates that it's going to be pertaining to what? Life. Okay, so check this out. Super ugly word. Bio, geo, meaning it's going to be pertaining to
Environment.
environment or like rock and life geology. So biogeochemical. Yeah, right. We are going to be discussing biogeochemical cycles. And I'm going to go back to my regular way of writing my vocab. I don't like the colon. All right. Life, earth, chemical, and cycle. As we look at this, matter moves all over our planet. Like from the biosphere to the geosphere, back and forth, and they're all related and intertwined because we live in a really complex planet. When we're looking at this, we're going to say that this, biogeochemical cycles, these are simply the exchange of matter through various levels of our biosphere. Biosphere, I don't know why that came out weird. various levels of our biosphere. I'm going to write, it sounds like there's a period there, but I'm going to say more. Through the biosphere, geosphere, and atmosphere. Now, there's one more in there that I didn't write down, the hydrosphere, but because we're going to be talking about the oceans, I thought that one might just be linked in already. All right. When we talk about the exchange of this matter, it can happen through biological processes, the bio part. It can happen through geologic processes, the geo part. So like through rocks, right? We have caves and things like that. And it can happen through chemical processes, whether it be through biology, geology, or through atmospheric activity, or oceanic, or water activity as well. Now, right off the bat, I don't think I have to write this down. I have some amount of energy, and I've used a bunch of energy in my life. If I die, does all my energy die with me? No. Mm-mm. You cannot destroy energy. It can't happen.
Oh, yeah,
This is a fundamental idea. It's a law.
Yeah.
We're not going to define this, we'll just talk about it, but I do want to make sure we all are aware of it. It's the law of, to save something is to conserve. The law of conservation of energy. Now, energy cannot be created nor destroyed. The weird part about this is it often seems like it is. You cannot create nor can you destroy energy. That's why, like perpetual motion, if you guys have ever seen it, it doesn't really work because you can't do that. Now, when you think about energy being destroyed, for example, let's say I have a cup of gasoline, light it on fire, and I just walk away for like an hour. Doesn't burn down the school, it's safe, whatever, hypothetical. When I come back, there's no more gasoline. It looks like it's been destroyed, right? All the energy that was held within my gasoline didn't get destroyed, but something happened to it. It changed, right? It changed forms. Specifically in that situation, it changes to a few different things. Primarily, it changes to heat energy, but there's also light energy that comes off of it, as well as there's going to be some fumes that float up, and they're still around. They're just not concentrated in a bucket of gasoline. Okay, energy cannot be created nor destroyed, which means, man, we got a lot of energy on our planet. We saw that 100% go to 10, go to 1, go to 0.1. Those aren't really just disappearing. They're being used and changed into other stuff. The primary way that any trophic level loses their energy is through heat, primarily. Not always, but oftentimes it is. Now, here's where, sad that RJ's gone, but this works really well for our purposes today. I'm going to pick 4 random numbers. Don't write these down yet. I'm going to ask you guys to do a little bit of research. It's fine if it's in the textbook. If you want to draw some pictures, just kidding. I want you to draw some pictures, not if you want to. Couple examples. I have some work up here from last year talking about the different spheres. Just those little tiny squares, right? So I see that there's a square that somebody made representing different parts of the atmosphere. Here's one that people made looking at weather. Here's one that we looked at cloud formation and so forth and so on. They're all weather related in that situation, with the exception of the first. I want you guys to draw me one cycle, and you're gonna write it down and you're gonna present it maybe today, maybe Monday, just really briefly informal, just like we did the other one. But I'm gonna stand up here, and as you're presenting, I'll write down what you're telling me about your system or your cycle that I'm about to give you guys, okay? Cool. So, 4 cycles. I'm just gonna put numbers on them. Don't write them all down yet, okay? If it's in red, you don't need it. The first one, we're gonna talk about the water cycle. You do not have to write these down yet. The water cycle. Okay, number 2, we have the carbon and oxygen cycle. And I'm going to do this for elements. Carbon is a C, a capital C. And oxygen, do you guys know the symbol for oxygen?
Yeah.
What? So that's carbon dioxide. O.
Oh, yeah, oh.
O2 is the elemental oxygen that we breathe, but oxygen exists on its own.
Yeah.
Okay, do you know another one? Water cycle for sure. Carbon cycle, maybe you've never seen. The life cycle is a good thought. It's not one that we're going to hit today. We have a nitrogen cycle. I don't know why this is coming out in all caps. nitrogen, capital N. And we have a phosphorus cycle.
Like, oh, wait.
So phosphorus is just another element. It's the yellow rock.
Oh, yeah.
It's the smell of matches. You're smelling phosphorus.
Gold.
What's up?
Gold.
Not gold. I'll show what I'm thinking of. I don't want to go grab. I have a chunk of that over there, but it smells, so I don't want it over here. That's not yellow. Show me real phosphorus. There it is.
Oh, curry powder.
No, you do not eat this. It smells like rotten eggs.
Oh.
But it burns really well, and it's crazy because it actually melts when you burn it. It's odd. Anyway, we have 4 of these, and there's 4 of you. Cool. Check out how well that works. So, I'm just going to go in alphabetical order, so I'll look at this. I'm just going to assign you each a cycle. For your whatever cycle you get, I want you to jot down like a brief description of what it is in a way that looks like notes, so that when you're talking, you can write it as a paragraph if you want, I don't really care. I'll write it in the form of notes when you do it. Okay, so going down the list, Brent, you get number 2.
Carbon.
You get the carbon and oxygen cycle. Okay, jot it down. I'll get us paper here in a minute. Cool. Let's see, next up, Jadester. Oh my gosh, we got 2 like 4 times in a row here. You, Jade, get the water cycle. Okay, next, Cecilia. You get nitrogen.
Wait, phosphorus?
You get phosphorus.
Oh, what?
Yeah, his last name's Cecilia. I just went in order and I just did random numbers to see who got what. Yes. So I'll write these down. RJ, if you're watching this and you're ill, focus on getting better. You should read about these in your text, though. And I lost my stylus. Just kidding. Found it. Okay. So water cycle. Who got that one? I already forgot him. Jadester. Who got carbon?
Me.
Okay, Zed. And we're just going to go ahead and write Jadester. All right. Nitrogen. Fredward.
Yeah, you did. Yeah.
And Bam Bam got phosphorus.
No way I got curry powder.
It's not curry powder. I promise it's not curry powder. All right. So we have 15 minutes left in class. I will get small pieces of paper cut out for you guys that I want you to make some artistic effort. I'm going to hang them up probably. So I'm not going to say, like, I don't judge your art, but try. Actually try. For this, you're going to do basic notes like we do here. So the water cycle, it's ugly to write everything down. I have a nice little picture for mine that's similar to the one or exactly the same as the one in the book. I am cool if you guys use a picture in the book. I'm cool if you would rather make your own picture that's different. I had a heck of a time trying to draw on my page the carbon cycle, just so you know. That's a weird 3-dimensional thing in your book. I don't love it, but cool. 15 minutes. Short notes on this, and then I'll get you pictures or pieces of paper for pictures. Everybody understand the assignment right now?
Yeah.
Cool. All right. RJ, if you're watching, your job is to read through this in your text. I'm not going to make you present because you will be helping me decide whether these people hit everything. Cool. There might be more video after this, but if not, RJ, feel better this weekend.